In this problem or video, I will be solving this problem where we want to find the weekly earnings where 55% of all the earnings is higher than that. So we are looking for a dollar amount on the x-axis where we know 55% of all the dollar amounts earned is higher than that. Drawing our normal curve, I marked the center as $441.84 for the mean, and standard deviation is 90. So I'm looking for a dollar amount on this x-axis. And I want to know that dollar amount, is it to the left or is it to the right of the mean, so that 55% of the area under the curve will be to its right. My logic and my knowledge of the normal curve should help me. I know the right half of the normal curve is 0.5, has 0.5 probability, or is 50% of the area under the curve. That means that that x value, which is unknown to me and I'm solving for, must occur to the left of the mean, so that the area encapsulated between it and the mean will be added to the 0.5 area and will generate 55%. So if I find that x value, that question mark, so that 0.05 of the area under the curve falls between it and the mean, then this total area to its right will be 55%. The 5% plus the 50% will generate 0.55. Just with that, I can now go to the z-axis and mark it. 0 will be written for the mean, and I know for the value I'm looking for, I should have a negative z-value because it's a value that occurs to the left of the mean. The negative z-value that I'm looking for must equal that x value that is my unknown minus the mean divided by standard deviation. So if I can use the normal table to find that z-value where 55% of the area under the curve falls to the right of it, then I can plug my numbers in here and solve for x. But I need to make one more observation before I do that. This white left tail is 1 minus 0.55, which is 0.45. I need that because when I go to the normal table, negative z table, I must recognize that the numbers listed within the table, all these 4-digit numbers listed within the table, are telling me the area to the left of the z-values that I would look up. So whatever the z-value is that gives me a negative, that gives me 0.45 to the left of it would be the z-value that I must use in my calculation. I will scroll up and down and I will scan the entries within this table so that I can find a number that comes as close to 0.45 as possible. The two numbers that do that are listed right here. So the 0.45 falls between them, and that tells me that if I find the z-values for these two numbers, then my z-value for 0.45 area would be somewhere in between them. For this left value, the z is negative 0.12. And for this right value, the z is negative 0.13. How I know that is I go to the left column, left edge of the table, and then I find negative 0.1 right here. And then I will also follow those two columns all the way up to the margin values. Going up, I see 0.02 and 0.03. So that's how I know that the z-values are negative 0.12 and negative 0.13. So the question then is, which one of those better serve my purpose? Remember, I wanted this area, white area, to be 0.55. So if I go with the 0.12, the negative 0.12 value, notice it's 0.4522. 0.4522. So that puts me slightly, instead of 0.45, it's slightly bigger, and it puts me over here at 0.4522. So that cuts into my 55%. So I'd better go with the more negative number, the negative 0.13, which gives me a probability of 0.4483. 0.4483. So I'm going to make a mental note of that, and when I come to my original sheet, I will say that on the z-axis, the negative 0.13 has 0.44. Let me make sure what that was. 0.4483. 0.4483. associated with it. So, but for now, the 0.45 is a good estimate. It's pretty close to it. So I will go ahead and use the negative 0.13 over here in this calculation. In order to perform my calculation and solve for x, I will turn the left side of this equation into a fraction. I will divide it by 1, and of course any number divided by 1 is itself. So now I have negative 0.13 divided by 1 equals this right side. When I cross multiply, of course, the multiplication of these two numbers must equal the multiplication of these two numbers. That's what cross multiplication does. So essentially I have 1 times x minus 441.84 equals negative 0.13 times 90. Now any number divided by, any number multiplied by 1 is itself. So x minus 441.84 equals negative 11.7. So I will keep the x on one side and take everything else to the right side. The negative 441.84 taken to the right side will change its sign and will become positive. So I will end up with negative 11.7 plus 441.84. And that gives me an x value of $430.14, meaning that 55% of all production workers have earnings higher than $430.14. Using Excel, now I solve with the function norm.inverse. Probability I use is 0.45, which is the area to the left of the x value I want to solve for. Mean, comma, standard deviation. Hit enter and you solve $430.53. This is different and slightly higher than $430.14 that we solved with table. Reason for that is because the z-value I used from the table had an area to the left of it which was equal to 0.4483. If I use that in my norm inverse function, Excel will return a value of $430.14, which is identical to what I solved with the table. Thank you.